Here's some more problems that kind of give you examples on what to do on the larger than 4.5 worksheet. They're not from the worksheet, they're just problems like this. And I had a little glitch on my computer, so I already did this one, so I'm just going to go through it, but I don't want to rewrite it again. So if we look at this problem, this was number 15 of our examples, and 4x cubed sine x to the fourth dx. And we're going to try to get this in the form of sine of u du, because we know the antiderivative of that is the negative the cosine of u plus c. And when we notice this, we can see that if we call this u, the derivative of that's going to be 4x cubed, and we've got it right here, so we'll be in pretty good shape. So we just have to kind of write this a little bit differently, and we'll just put the 4x cubed on the right, and then we'll just decide that we're going to let u be x to the fourth. And if we just substitute that in, instead of writing sine of x to the fourth, we write sine of u, and you can see what we got there. But we have to have du. If we look at our formula up here, it's sine of u du. So how do we get du? Well, we just take the derivative over here of both sides. So the derivative of u is du, and the derivative of x to the fourth is 4x cubed dx, which is an exact match. So instead of writing this, we can write du, and we're ready to go. And we know that that's equal to negative the cosine of u plus c from our formula above, right there in red. And what was u? X to the fourth, and you're done. Well, that didn't take very long, so let me try number 16. And again, this might throw you, but remember, what's the derivative of 1 over x? Negative 1 over x squared. So that looks like that's going to be a good candidate for part of our du. So what I'll do is I'll take the 2 out. We always like to take the constant out. Although up in the first one, up here I didn't take the constant out because I could see that it was going to play right into my derivative. But I don't think this will. So I'm going to take the 2 out, and I'll rewrite it as 2 times the integral, and I'll write the sine of 1 over x times 2, I'm sorry, I took the 2 out, 1 over x squared dx. Okay? And again, we're going to look at the same form. So we're going to try to call this u. We won't try, we will. So we'll say let u equal 1 over x. We can rewrite this now. 2 times the integral of the sine of u times my 1 over x squared dx. So now I've got to get a du, so I'll take the derivative of both sides over here. If I take the derivative of u, I get du. If I take the derivative of 1 over x, what do I get? Negative 1 over x squared dx. Remember, this was actually on one of our flashcards. Now the only difference between this and this is a negative sign, so I'll just divide by a negative 1. So now I have negative du equals 1 over x squared dx. And you see you have a perfect match. So instead of writing 1 over x squared dx, I can write negative du. All right, and the only difference is this negative, so we'll take this negative out. Put it in front, so we have negative 2. And there we go, we got sine of u du, and up here, the antiderivative of the sine of u du is negative the cosine of u plus c. We just have a negative in front of it, so that's going to equal negative 2, and that's going to be negative the cosine of u plus c. And a negative times a negative is positive, so we just have 2 cosine of u plus c. But what was u? U was 1 over x. So there you go. So there's a couple of examples. I hope that helps.